So we are going to work on exponential models. So we've talked about linear models, we've talked about quadratic models. Now we're going to look at exponential models. Okay? So what we've seen before in the previous lessons is that if it's a linear model, it grows by a constant rate, right? So you have the slope, and the slope is going up by the same amount. We did the first difference, and the first difference was constant, right? Or it has degree 1. You guys remember all of this? And then it would be a linear, a straight line. With a quadratic, what would be constant in the table of value? The second difference would be constant. Degree would be 2. What would be the shape of the graph? Correct. Now we're going to look at an exponential. Okay? So with the exponential, we know we've seen that before, right? With exponential, the first difference is not constant. The second difference is not constant. Not even the third difference is constant. What would be constant when we talk about exponential? Same rate, same ratio, right? So remember, we had to do not differences anymore. We don't do y2 minus y1. What do we do to find the ratio? Ratio means divide, right? So we do y2 divided by y1. Okay? So with so if I'm talking about an exponential model, okay? So you have a constant percent rate, okay? So which means constant ratio, y2 over y1. And we will have, in the table of value, the growth or decay factor. It depends if it's growing or decaying or going down, they're equal. So the growth or decay factors are equal. And then the graph represents an exponential curve. And remember, with an exponential curve, I have something that's like flat almost on one side, and then it grows exponentially, or it decreases fast, it's a decay, and then you have a flat on the other side. And then when it comes to the equation, I will have an equation that looks like this, where I have y equals a b to the power of x. And if you remember, guys, the exponent is the variable when it comes to exponential. It doesn't matter. It could be inside or outside. It's the same thing. I don't even have to put the bracket if I want to. Okay? So it could be written like this, or you could write it as like this. It's the same thing. And what letter represents the initial value? A is the initial value, and B is your growth or decay factor. Right? You guys remember, it's called a growth or decay factor. A lot of you on the test, you did not remember that word. So you said growth or decay rate. It's not the rate. The rate is a percentage, right? So if I say you're increasing by 20%, right? Your rate is 20%, but your growth factor is 1 plus 0.2, which is 1.2. Okay? This is called your growth factor. Your growth rate is at 20%. Okay? We'll talk more about this. But remember the terminology. These terminology are important because they're two different things. And notice that the exponent is the variable, right? Is the letter x, is the variable. And this is how I know in the equation that this is exponential. Are we okay with that so far? Okay. Now, so the equation or the exponential equation is y equals ab to the power of x. B is my growth or decay factor. If b is greater than 1, the relation is growth. And remember that this B, which is your growth factor, B, is equal to 1 plus your growth rate. Right? So if I say, for example, the population is growing by 7% per year. What's my growth rate? Growth rate is 7%. What would be my growth factor? One plus, what's my growth rate? Which is 0.07, right? So my growth factor is 1.07. Right? Because remember in your equation, if I go back to the equation where we did y equals a 1 plus I to the power of x, remember that? Remember that? This is for the growth, 1 plus I, right? I is my growth rate. I is my rate. When I add the 1 plus the rate, that gives me my base, which is 1.07, which is my growth factor. You guys understand that? So if you want to find the growth rate, if you want to find I, right? If you know what B is and you want to find I, so this here, that's your B, right? So B is 1 plus I. If I know that B is 1.07, if I know that my growth factor is 1.07, and I want to find my growth rate, I want to find I, what do I do? So I'm going to have to bring the 1 over. What do I do? Subtract. So 1.07 minus 1. And that gives me my growth rate, right? So the growth rate is equal to the growth factor, take away 1, right? Which is going to give me 0.07 or 7%. Right? So remember that your growth rate is I and your growth factor is B. Does that make sense? It won't make sense unless you understand the difference between growth factor and growth rate, the difference between the words and the letters. Now, if your base, which is your growth factor or decay factor, is between 0 and 1, is this a growth or decay? It's a decay. So the relation is decay or decreasing. You know what? I have a spelling mistake here. I'm going to make it as growing and decreasing because it's a growing or decreasing, right, or decay, sorry, because it's a decreasing or a decay, how would I find my decay factor? What do I have to do to find my decay factor? Remember from the formula. What would be my formula for decay? So, if I'm going to look at the whole equation, y equals a 1 minus I to the power of x, right? And that I know it's a decay because I'm decreasing, right? So this is my base. So the base, which is the decay factor, is equal to 1 minus the decay rate, right? So B is 1 minus I. is the rate. And then to find the decay rate, so to find the decay rate, to find I, what do? Bring what over? I. Okay, so if I bring the I over, it's going to become B plus I equals 1. Then I just want I by itself.
I equals 1 minus B.
Correct, because I'm going to bring the B over here, and it's going to be I equals 1 minus B, right? So to find the decay rate, which is I, you're going to do 1 minus the decay factor, so 1 minus B. Okay, so things that you need to get together is decay factor is B, or growth factor, that's B, and then the rate, it's the I, it's a percentage. Are we okay with that part?
Can I write that down? Rate is B.
Rate is the I, and factor is the B. If you have a table of value and the question is asking you which model represent exponential relations. So which model represents exponential relation? What do you need to do to find out if it's exponential or not? There won't be minus, because minus means it's either
Divide.
you have to divide, you have to find the ratio. Okay? So you need to find the ratio, and then if your ratio is constant, then you know it's exponential.
Is it y2 divided by y1?
Correct. So it's y2 divided by y1. So I can do 25 divided by 35. And that's going to be 0.71. 15 divided by 25. And that's going to be 0.6. And 5 divided by 15. That's going to be 0.33. And then what can you tell me about the rate? Is it constant? Okay, so the ratio is not constant, therefore it's not exponential, right? Okay, in the second example, if I do 64 divided by 51.2, I'm gonna get 1.25. 80 divided by 64, that's going to be 1.25. And 100 divided by 80, that's going to be 1.25. So if I look at this is the growth factor or the ratio. What can you tell me about the ratio here? Therefore, is it exponential or not? It's an exponential growth, right? And how do you know it's an exponential growth? Because the rate is greater than 1, correct. Not the factor, growth factor.
So it's exponential growth is the ratio
consider that it's exponential, but then we're adding to it, it's an exponential growth because we know that because the rate is, or the ratio is greater than 1, right? We're adding to it, we're explaining more here. Are we okay with this?
Yeah.
All right. So the question is asking you which one is exponential. Yeah, D is exponential. Yeah, and how do you know that?
I forget the proper terminology, but right above the x there's the number 2, and it's not a straight, consistent line.
It's not straight, and then you see that it kind of like, it's a curve that is slowly increasing at first and then faster increase after. Okay?
Okay, I don't feel the rest.
Okay, so this is a straight line, this is not exponential, right?
Yeah.
And this is exponential, and you know that the curve appears to be exponential through slow growth. Okay, equations E and F, which one is exponential? E because
Exponent variable.
the exponent is the variable. And what is this? Quadratic. All right, so the next question, they're asking you to determine the growth or decay rate of the following equations. So how would you find the growth or decay rate? What letter are you looking for and what do you know?
I'm looking for D.
I. Growth or decay rate, that is Knowing what? So in this case, is it growth or decay? Growth. So I know that this right here, which is my factor, my growth factor, right, is equal to 1 minus I or plus I? So this number, I got it because I had to do 1 plus I, correct? Okay, I'm looking for I. What do I do? Bring what over?
Sorry.
Bring the 1 over, right? Because the I is already positive, you want to keep it there. So if I bring the 1 over, it's going to become 1.071, take away 1, equals to the I. Right? So that's going to be 0.071 equals to I. So what's your growth rate in this case?
No, sorry, 7.
7 what? 7.1, right? So the I is 7.1%. All right. How about the second one? Is it growth rate or a decay rate? It's a decay rate, so that means my decay factor here is 1 minus I, and that gives me 0.92, right? I know it's a decay, so I have to use the 1 minus I. Okay, what do you do now?
It would be I equals 0.92.
So first step, bring the negative I over to make it positive I, right? So bring the negative I over, so it becomes plus I. Right? If I move it to the other side, now what do you do? I want I by itself.
You do the same thing that you did to the left.
So what do you do?
0.92 minus 1.
No, because
Oh,
you're going to bring the 0.92 over, and it's going to become 1 minus 0.92. Right?
so I almost got it.
Almost. It's 1, take away the 0.92. Your rate is never going to be negative. So what is that? 0.08. Which is 8%.
How do you find the percentage? Like how?
You multiply by 100.
The winter is very depressing.
All right. So compare the initial value and compare the growth or decay factor. So the equation of two colonies of bacteria are shown below. You have colony A, which is P equals to 100 times 2 to the power of T, and the second one, colony B, is P equals 103 to the power of T. Can you compare the two for me? So tell me what is different, what's the same, what, or like, what do you know? What are these numbers?
And the same initial value.
What's your initial value for both? 100. So they have the same initial value. That's right. Okay? One's tripling and the other one is doubling, right? Colony A is doubling, colony B is tripling, right? So they don't have the same growth factor.
So that's a growth factor, right? Not a
Yeah.
growth rate.
That's right. So which one is growing faster?
B.
B. So you're gonna see the difference if you use decimals, right? And then you graph it. You're gonna see that they both are gonna start at 100, but then you're gonna see that colony A is growing this way, right? While colony B is growing at a faster rate, right? Because after 1 day or whatever, how many days, right? You're gonna see that colony A is gonna have 200, while colony B is gonna have 300, right? Colony A is gonna have 400, colony B is gonna have 600, right? So you're gonna see that they're going to, colony B is gonna be faster. So this is going to be colony B. And this is going to be A. Okay? Now if I use decimals and I graph the two, so this is the first, this is colony,
Is it ever gonna end?
it will never end. Okay. And then if I have y equals 100, 3 to the power of x, you see that the blue one is steeper, right? Now they're asking you for the second part is what happened if the initial value for the first colony A is 200? What happened if instead of having an initial value of 100, I have 200? So I'm gonna change this to 200.
When did the intersect hypotenuse?
So we see that at the beginning, right? At the beginning, we have more in colony A, but then after the first round, almost, right? We see that colony B is going to be increasing faster than colony A, right? So you see that right here, this point right here, we see that they have the same number of bacteria, but then after that, colony B will start growing faster. At the beginning, only for the first round,